Okay, so you can see that. 4.5. So 4.5, we're actually again going to be applying properties to logarithms. And again, I just say logs, because why would I ever say logarithms? I'm just asking for a little tongue twister there. So applying properties to log functions. So
I'm annoyed
why?
because I'm thirsty and I can't get my food to drink.
Sorry. So with the product property, and we're gonna just kind of list all of these out, and then we're gonna go back and give you some example of these. So with the product property, this basically states that addition turns to multiplication, multiplication turns to addition. So if you say you had log of, and we'll just say log base b, it can be any base again, right? Bases to these. And let's say it was m times n. So with the product property, you can instead turn this multiplication into addition, meaning I'm going to take log base b of my first term and my first term only. And I'm going to add that to log base b of my second term, which is n. Okay, log base b of my first term plus log base b of my second term. And I want to remind you, these go both ways. So I'm first going from multiplication to addition, but I could go the opposite way, and I could take addition to multiplication. So this is communicative, it's going both ways here. Where there's a quotient property, dang it, I said it. Where there's a product property, there's a quotient property. I'm getting ahead of myself. Okay, so the quotient property, think about product, multiplication, quotient, division. So division and subtraction go together, okay? So let's say we have log base b of m divided by n. Okay, again, division's going to turn into now subtraction. So we're going to take log base b of my numerator. Okay, and again, division, subtraction. Log base b of my denominator, which is n. Once again, these work both ways. If you start with something larger, you could also condense it to this smaller version with division. What's important to remember with these is they are equal though. So the reason that this property works is if you were to first multiply m and n and then figure out the log of that value, that's the same as if you found log of m and found log of n and added those two values together. So the final and last one is going to be the power property. That's a y. So with the power property, we're just simply dealing with exponents. So at a certain point, we don't like, if we're not able to cancel out an exponent or cancel out a log, we don't like to deal with the exponent up in that log. So if we had a log of base b to the n with an exponent of n, okay, that n is up in the exponent. Quinn, put it away. We can do this.
Chromebook.
We can do this thing instead where we throw the n out in front. So it's now n log base b of m. So again, this works in the reverse way. If you have a number out in front of a log, you could throw that back up to the exponent. I think this is the one that some people like, you hate it or you love it. Like you totally get it or you're like, I don't get how these numbers are switching in places. So let's do a couple of examples of these. I have to do it over here. Otherwise they can't see it. So you can see on top if I move this up a little bit more. So let's do, let me think of a good one. I'm gonna do two at once. Let's do log base 7 of 3 times x over 2. Yeah, let's do that. Log base 7 of 3 times x all over 2. So let's think about this. What are some of the big things you're seeing? Good, division. What else are you seeing? Do you see anything else? I guess I should say. What kind of operation happens between a 3 and an x? Good, multiplication. So I both have quotient and product property. Okay? Specifically in the directions, let's tell you to expand. So I'm starting with these condensed sides, and I want to try to expand them to be the more drawn out versions. So I first always want to deal with division when I'm expanding. It's hard to deal with that multiplication up top when I still have this division happening. So I'm going to have to take log of everything on my top, right? That's what this property says. Log of my numerator subtracted from log of my denominator. So we have log of my numerator subtracted from log of my denominator. Again, always keeping that same base, right? That log base 7. Questions on that so far? Awesome. What's the next step I can do? We kind of talked about it. The 3 and the x. This product property. Now I have the log of base 7 with 2 numbers multiplied together. I want to take log of my first number, right, and add it to log of my second number here. So we're dealing with just this part. We have to leave the rest of it on there, but we're just splitting up this 3 and the x. This one is a tough one. I wanted to talk about it for that reason. When you have 2 variables multiplied together, like m and n, it's obvious, like, oh, that's multiplication. But we don't always think about a number and a variable as multiplication together. So we will take log of base 7 of 3 and add it to log base 7 of x. I still have to add on my log base 7 of 2, or not add on, subtract on, right, or subtract off. It's a Monday, log base 7 of 2. So a hint for you. We want to think, how many terms did we have total to start with? Here's 1, 2, 3. The amount of terms you have is the amount of logs you should end with. So I have 1, 2, 3. If that number matches, then you're good. Questions on that? How confusing was that? All right, let's do some more. So I'm gonna get rid of these.
Is that just like the end then?
Yeah, very good, that's the end. So good question. So how do we know we're at the end though? Do I have any exponents left?
No.
Do I have any multiplication left? Do I have any subdivision left? Good, that's how we know we're at the end. When we're down to no exponents and just addition and subtraction. That's when we know we're at the end. Good question, Jessica. All right, let's do. Let's do this one. I'm gonna give you a minute to go ahead and try this one. I also really need to take attendance.
I need to look it up.
Yeah.
Okay.
There we go. So think about how many terms total do you have?
Yeah,
exactly
but-
what are the exponents being applied to, and just be careful with each of these steps. Okay, keep working, take about 30 more seconds. All right, how many total terms do I have? Meaning how many logs should I, yeah, good, three total terms, right? So we want to say there's multiplication between 5 and the x. There's multiplication between x squared and y squared. Every operation, right, we can separate that out. So if there's an operation between these and these, that means I have 1, 2, 3 total terms. Okay, so when I have my final answer, I should have 3 total logs. So what's the only property that I'm using right now? Yeah, very good, product property. Because I have multiplication, again, same directions, we're just wanting to expand these. Since I have multiplication, I'm turning that into addition. So essentially, let's get my 3 total logs out here. I have log base 2 and log base 2. So we want to have log base 2 of 5, that's my first term. Log base 2 of x squared, that's my second term. Log base 2 of y to the 7th, with addition in between each and every one of these. Okay, so log base 2 of 5, log base 2 of x squared, log base 2 of y to the 7th. And again, multiplication turns into addition. So now, do you see anything that would make us keep going?
You put the exponents in the logs.
Nice. Our exponents. We can't stop if we have exponents. So be very mindful of the steps we just took. We dealt with multiplication and we asked if there was addition or division, right? There was no division, so we moved on to multiplication. So you deal with them in that order: division, multiplication, then exponents. When we're expanding, exponents should be the last thing you touch. Now I'm going to throw squared out in front and 7th out in front. Log base 2 of 5 plus 2 log base 2 of x plus 7 log base 2 of y. And earlier I mentioned be very careful as to know what exponents these numbers apply to. It's so frequent that I see people combine 5x squared and put the 5 out in front, or the 2 out in front of the 5 and the x. Okay, the exponent only applies to what it's directly touching. More questions? Guys are kind of rocking this. Like, I'm surprised. I feel like I need to slow down. Am I good? Sweet. So I'm going to introduce all these same properties, but with natural log. So if you don't wanna write these again, you don't have to, you can make a little side note, like all the same are true with natural log. I wanna make sure that I know I wrote these out for you. So the product property is the exact same thing. If I throw a natural log of m times n, is it not just gonna kind of be the same thing? Where I take natural log of m and add it to natural log of n. Same property with a different type of log. Quotient property. Natural log of m over n. Take the natural log of my numerator, which is m, subtracted from the natural log of my denominator, which is n. The third one that we went over was the power property. And I think you already kind of know where this is going, but it's the same thing, natural log of m to the nth power. You end up throwing that exponent out in front. Oh, no way. Who knew it was the end of class? I didn't, sorry. We will keep going over this tomorrow. Nice job though, guys. You did awesome. Yes, I will take that. Thank you. See you guys on here.
Have a nice day.
I will leave this on for just a second so you can kind of grab those. Sometimes I forget that like we end this class period. I just get like a little like warning zone and I just keep going.
Let it